Hello, welcome to this video on the law of cosines. We just finished studying the law of sines, and this is a similar strategy in that it allows us to solve for non-right triangles, but one of the beautiful things this one does for us is that it takes away the situation where we run into the ambiguous case. Inherently, because of the features of the cosine function, it will solve for both triangles just in the arithmetic that we end up doing when solving the triangle. So let's begin. What we'll notice is that there are three variations on the formula. Each one has a similar pattern though. It always begins with a side. In this case, the first one, it begins with the square of side A, and then it ends with an angle that matches, so angle A. So it's kind of that same angle side pair type of thing happening. However, we are actually choosing which formula to use by which angle side pair we do not have completed. So if we had angle A but not side A, we'd use this first formula, or vice versa. If I had side A but not angle A, I might use this first formula. The other ones happen in a very similar fashion. Okay, so what I'm going to do is I'm going to fill these in, and the b squared is then followed by a squared plus c squared minus twice ac times, and this is, I should mention specifically, this is multiplying, okay? Some people get confused by that. So times the cosine of angle b, okay? And then c squared has a squared and b squared in here minus twice ab times the cosine of, you guessed it, angle C. Okay? So again, the side out in front matches the angle that we're dealing with. Okay? So let's begin looking at some of the ways we apply this to triangles. So let's begin with our first situation. This is a side angle side case, but we might not know that going into it. So what I always do is I just sketch a triangle. Now remember, just as I said in the previous videos, it doesn't matter how you sketch the triangle. It is just an organizer for us. Okay? So here I'll put angle A and side A opposite it, angle B with side B opposite it, and angle C with side C opposite it. So we begin by putting in angle B, which is 81 degrees, and then side A, which is 22, and side C, which is 19. Now it becomes apparent why this is a side angle side situation, okay? Because I have a side, an angle, followed by another side. So this is the side angle side situation. This works really nice with the law of cosines. Now in this case, I have angle B, and so I'm going to choose the formula from the previous work that uses angle B. Okay, I'm going to use the one that ends with that cosine of angle B. Now the rest of the formula went like this. It started with b squared in the front is equal to, and then it has a squared plus c squared minus twice ac times the cosine of b. Okay, so now we just go ahead and fill in our information. Again, I chose this because I have angle B, so I'm choosing the formula that uses angle B. Okay, and that's going to help me solve for side B because that's the one out by its lonesome out there. Actually, I could solve for A and C also, but it just works out really nicely this way. The key thing we need to remember is we only want one unknown in the whole deal. So when I fill in everything, I better end up with only one unknown variable. And that in this case will be b squared. I don't know what b is. But I do have a, which is 22 squared. I do have c, which is going to be 19 squared, minus twice times 22 times 19 times the cosine, I ran out of room on my screen, cosine of, let me zoom out just a little bit, 81. Okay, I'm going to put the whole right-hand side in my calculator all at one shot. Now use parentheses and everything and make sure your calculator's in degree mode because our given information was in degrees, okay? So let's put that all in the calculator at once. Okay, so what we get on the right-hand side after we put it in our calculator is approximately 714.22. But here's the key. We have to remember this is equal to b squared. It's not b yet. That's b squared. So now I need to take the square root of both sides. Okay, so let's take the square root. And what we're left with then is the value of b. So we'll get b is equal to positive or negative 26.72 approximately. 26.72. Now, we need to realize here that this positive negative stuff doesn't really make sense in the context we're dealing with a side length of b. It doesn't make sense for us to have a negative side length. So I'm going to erase the negative one and just leave it with positive, okay? So we're just going to have the positive side length. Alright, so equals 26.72. So that's the length of b. Now what we realize is that I have an angle side pair. Oh, well, we might as well finish this off with the law of sines then, since that's a much faster method to use. Okay, so that's what I'm going to do. I'm going to set this up as the sine of 81 over 26.72 is equal to the sine of angle A over 22. All right, so then I cross multiply. I get 22 times the sine of 81 is equal to 26.72 times the sine of angle A. Divide both sides by 26.72. 26.72. And let me give myself a little more room to work with. Everything's zooming out so far. And then I plug in this left-hand side into my calculator and see what we get. I approximately get 0.813, and that will be equal to, as things clear out on the right, that'll be equal to the sine of A. So now I have to take the inverse sine, or the arc sine, of both sides. Okay, so the inverse sine of both sides, and let's see what we get. I put that into my calculator, and wait for it. I get 54.4 degrees for A. All right, A equals 54.4 degrees. Okay, cool. So then the last thing we have to do is to solve for angle A, or sorry, angle C. We just did angle A. And there's a couple ways, and I debate this. The fastest way to do it is to subtract 81 and angle A from 180 degrees, and that should give us angle C, unless we've messed up along the way with the measurement of angle A. If that's the case, we're not going to have a way to check for that. So what I usually say is, let's solve for angle C the same way we did angle A, and then add our angles together and see if they come out to 180 degrees. So let's do that, okay? Okay, so I just rearranged my screen a little bit to give myself some room. And now I'll go ahead and solve for that last angle C. So I'll go the sine of B again, which was given to me, 81, over side B, which I had to calculate. Hopefully I didn't make a mistake in that, or everything else is going to be messed up, is equal to the sine of C over 19. Okay? And then we're going to go ahead and solve it the same way we did before. 19 times the sine of 81 is equal to 26.72 times the sine of C. Divide both sides by 26.72. 26.72. And plug that left-hand side in my calculator here. Okay, so I get 0.702 is equal to the sine of C. And so now I need to take the inverse sine of both sides. Okay, so angle C will equal the inverse sine of 0.702. And I get 44.6 degrees is equal to C. And I do a rough check here, and things do work out just about. Save for some rounding errors, my three angles come out to 180 degrees. Okay, so that's excellent. I've got my angle C plus angle A plus my angle B comes out to 180 approximately. So so that's great. And then I also found my missing side B. And there we go. That's our first application of the law of cosines. Okay, so this next scenario is the side case, and this actually has a special consideration to take into when we solve it. So I'm going to go ahead and sketch out the triangle. Alright, so I'm going to have my three sides, A, side A, B, side B, C, side C. And I'm given A is 8 units, B is 12 units, C is 10 units, and I don't know the three angle measurements. So the special consideration we have to have when we have a side case is we must solve for the angle opposite the largest side first. Okay, let's actually even write that down because it is important. Okay, we must solve for the angle opposite the largest side first. That's really important. So in this case, that means I'm going to solve. So in this case, I'm solving for angle B first because the biggest side is B. That's 12 compared to the 10 and the 8. So I'm going to solve for angle B first. That is opposite the biggest side. So I'm going to set up with the formula that B squared is equal to A squared plus C squared minus twice AC times the cosine of angle B. Alright, so let's go ahead and plug in our values that we have. This time I've got side B. So I've got 12 squared is equal to 8 squared plus 10 squared minus twice 8 times 10 times the cosine of angle B. Oh, you just got to hear my dog. So then I'm going to do a little simplification. I've got 144 is equal to 64 plus 100 minus, let's see, 160 times the cosine of B. And this is the point where a lot of people make mistakes, okay? So I do the next step of simplification and people error here. What they want to do is this. Alright, I'm going to write that. What they want to do is this. Now, don't write down this next step yet because it's wrong, okay? People want to do is they want to say, oh, well, this is 144 equals 4 times the cosine of B. And that's wrong. Because according to the order of operations, I would have to do this multiplication before I could do the subtraction of 164 minus 160. But people forget about that all the time. So do not fall into that trap. We cannot do that. We have to follow the order of operations. So what does that imply for us then? Well, what that means is I'm going to go ahead and I will take away 164 from both sides. Okay. giving me negative 20 equals negative 160 cosine B. Okay? And then I will divide by negative 160 on both sides. And there we go. I got a little crazy spinny there. And what I get is I get 1/8 equals the cosine of B. And so then angle B is equal to the inverse cosine of 1/8, or 0.125. And I put that in my calculator, and I get 82.8 as degrees is my value for B. Okay. Then I have my angle side pair. I now have that pair, so I can go ahead and set up my two proportions. I can say that the sine of 82.8 over 12 is equal to the sine of C over 10, and sine of 82.8 over 12 is equal to the sine of A over 8. And then I would solve both of those using the law of sines. In the interest of making this video just a tad bit shorter, I'm not going to go through that process to find the final answers there, but that would be where you'd want to go at this point. Okay, so let's look at an application word problem. In a junior baseball league, the pitcher's mound is 40 feet from home plate, and the bases are 55 feet apart on the square field. How far is the mound from first base? Okay, cool. So let's draw this situation out. And draw my triangle. And I'm going to put home plate down here. And the pitcher's mound. And we've got, let's see here, first base. All right, and it says the pitcher's mound is 40 feet from home plate. And then it says the bases are 55 feet apart on the square field. So this is 55. How far is the mound from first place? Okay, so this is a square field. Now, if you remember geometry, hopefully, the squares have 90-degree angles. So if I were to extend this over to third base, I would have a 90-degree angle in here, all right? Now, what that means is that, if I can erase something here, what that means is that this angle down here is going to be 45 degrees, this half of that. Okay? So I have a 45-degree angle down there. So this is my side angle side case. Okay? So what we want to find is how far is the mound from first base. All right? I'm going to label this with H because it's opposite angle H. And we'll use the formula then that H squared is equal to, now this is going to be value P, this will be value F, so I'm going to have P squared plus F squared minus twice PF times the cosine of angle H. Okay? So now I still don't know what H is, so H squared is equal to 55 squared plus 40 squared minus twice 55 times 40 times the cosine of 45. All right, so now I'm going to put the whole right hand side into my calculator. And that gives me that H squared is equal to 1,513.73. Now remember, that's H squared, so now I have to take the square root of both sides. And I'm just going to use the positive square root again because As I mentioned earlier, the negative distances don't really make sense in this application. All right, so I need to take the square root of the 1,513. All right, so I put that in my calculator, and I get 38.9 feet. That is the distance from the pitcher's mound to first base. Now we're going to take a look at an area formula that's derived from the law of cosines. I'm not going to go through the derivation here, but it's the common procedure to cover it at this point. And this is a great area formula because what it does for us is allows us a way to find the area of a triangle that is not a right triangle, or one where the altitude, thus the height of the triangle, is not given to us. So that's really neat. And what it does is it involves the three sides, A, B, and C of the triangle, and then something called the semi-perimeter. Okay? Semi-perimeter. And the semi-perimeter is half of the perimeter around the triangle. So it takes and adds up all the sides of the triangle. Here's all the sides, A plus B plus C, and then divides it by 2, which gives us half of it, thus the semi-perimeter. Hey, maybe you were thinking that it was a distance around a semi-truck. Now, I didn't think so. Anyway, so what we do is we're going to take the square root of the semi-perimeter multiplied by the product of the differences of each semi-perimeter and side length. Okay, so whenever we're using Heron's formula, we're going to go through and find the semi-perimeter, and then we'll calculate everything. Okay, so here we're going to apply this Heron's formula, and so what I need to do first is find that semi-perimeter. So S, the semi-perimeter, is going to be 12 plus 14 plus 17, okay, divided by 2. And so what that comes out to be is 21.5. Okay, now I apply my formula for the area, which will be the square root of the semi-perimeter multiplied by each of these differences. So, just move the screen, didn't mean to do that. 21.5 minus 12, 21.5 minus 14, and 21.5 minus 17. Make sure all that's all under my radical. And what I get, after I put that in my calculator, is an area of 83.03 units square. One last example, we're extrapolating the area to volume. So I'll find the area of the triangle's base and then multiply it by the height of that prism to find the volume of it. So we need to again start by finding the semi-perimeter. S, I keep moving the screen, sorry. So S is equal to 12 plus 10 plus 14 over 2. So that is going to be 18. So then I find the area with, again, the square root of that semi-perimeter, 18, times 18 minus 12, 18 minus 10, and 18 minus 14. And I throw that in my calculator, and it gives me an area of 58.79. So now I'll take the area of that base multiplied by the height of 2 to find the volume. So the volume will be approximately equal to 58.79 multiplied by 2. So the volume comes out to be then 117.6 feet cubed. That's how much concrete we'd need for this region. Thanks a lot for listening. Bye-bye.